We will now turn our focus to what is called returns to scale. This topic is also covered this week in an applied version in ECO235. Now, it is useful to think of what will happen if a firm changes its scale of production. So, when you think of scale of production, you think of the size of the production. Now, in the long run, you know that all the inputs can be changed, can be varied. So, bearing this in mind, how can a firm then increase their output? So, if a producer increased all the inputs of production in proportion, what would be the potential outcome to output? So, this is the type of question we are going to try to answer with returns to scale. This is what returns to scale is essentially all about. So it can be defined as the rate at which output increases as inputs are increased proportionately. So the rate at which output increases, so your output is your Q or your total production, as the inputs, and those inputs are your labor and capital, as those are increased proportionately. Now there are three different cases that you need to know as well as be able to apply, and you will be taught about the Cobb-Douglas function in ECO 235. So the three cases are increasing returns to scale, constant returns to scale, and decreasing returns to scale. Now, with increasing returns to scale, that is a scenario where your output more than doubles when inputs double, right? So think about it. You're doubling your input. So you double your capital, you double your labor. What happens to output? Output more than doubles. So that is a scenario of increasing returns to scale. And that is where you see the productivity of your factors increasing. A good example of that is your car industry. So, in that scenario, as you increase your number of workers and machinery, you find that people will tend to specialize and use high tech machines, and as a result, your outputs more than double with those increases in your inputs. The next returns to scale that we need to consider is your constant returns to scale. Now, there you have a situation where your output doubles when input doubles. So, if we double labor and capital, output also doubles. So, in this scenario, the size of the firm doesn't affect the productivity of the factors of production. Now, the last is your decreasing returns to scale, and that can be defined as a situation in which output less than doubles when outputs are doubled. So it's the opposite to increasing returns to scale. So here we again doubling our inputs, we double labor, we double capital, but output doesn't double, it less than doubles. So there you have a scenario where there's a decreased productivity of those factors of production. And a scenario could be that you have a very large firm that has become very difficult to manage, organize, and as a result of that, inefficiencies creep in, and this decreased productivity of your factors of production. So we're going to look at a figure 6.10, and it's split into two parts. And the first part A, shows you a scenario where you have constant returns to scale. So graphically, on your vertical axis, you have capital, and on your horizontal axis, you have labor, and it is given in hours. So in both figures, let's just open up the next figure. You will see that in both figures, for each of these inputs, capital and labor, it involves the same quantity of hours of labor and hours of capital. So if we look at our vertical axis in terms of these inputs, our input here, capital, in terms of machine hours, here we have 2 hours. And then to go to the next output level over there, we have 4 hours and 6 hours. And here you can see 5 hours, 10 hours, 15 hours. So for each output level, you're seeing this relationship of 2 hours for capital and 5 hours for your labor hours, and the same applies here. Right? So the production process in both figures involves 5 hours of labor and 2 hours of capital to produce a certain output. Now, if you look at figure A in figure 6.10, right, you can see that if inputs double from 2 hours of capital to 4 hours of capital, and labor doubles from 5 hours of labor to 10 hours of labor, we see that there is a doubling. If we follow this line OA, we see that there is a doubling of output. Output Q given by this isoquant, these isoquants, you can see that output has doubled from 10 to 20. Also notice that for constant returns to scale, your isoquants are equally spaced, right? And that represents that output increases proportionally. Now, if we move to figure B, we have a scenario where you have increasing returns to scale. And what you notice here is that these isoquants are moving closer together as the inputs are increased along the line, right? So you can see them moving closer together the further you move away from the origin. And this represents increasing returns to scale. Now, although we are not given an example of decreasing returns to scale, you would find that in that figure, the isoquants would move further apart from each other as you move along that line. Now, figure B, if we examine it closely and we look at the first isoquant given by an output of 10, we can see that is given by the combination of 2 machine hours and 5 labor hours. Now, what happens if we double our inputs from 2 machine hours to 4 machine hours and double our labor hours from 5 to 10? We can see that with a doubling of our inputs, output, which was initially 10 units, has more than doubled. So a doubling of inputs has led to a more than doubling of output. Hence, this is an example of increasing returns to scale. You can see it is beyond this isoquant that is equal to 30. This slide just describes what you saw in the previous figures, but just 2 important points to note. And the first is that returns to scale need not be uniform across all levels of output. So, for example, at lower levels of output, the firm could have increasing returns to scale, but as your output increases, so at higher levels, you could see perhaps constant and later decreasing returns to scale. So, returns to scale does not have to be uniform across all those levels of output. The next 2 points just describe what we've spoken about regarding those 2 figures. And then lastly, just a final point to note that returns to scale can vary considerably across firms and industries. So there are various examples of returns to scale, and other things being equal, we tend to find that the greater the returns to scale, the larger the firms in an industry are likely to be. So if you think about the example of the car industry being a typical example of increasing returns to scale. There is just an example regarding the carpet industry and returns to scale here. So it is useful to work through the example just for your own knowledge enrichment purposes. Now, remember that we are going to do an application of returns to scale in ECO235, but that skill is useful to understand and interpret returns to scale in ECO231. I will conclude this chapter at this point. Remember that you need to do section 6.1 and 6.2 for self-study.